สวัสดีค่ะท่านผู้ชมค่ะดิฉันจะบันทึกคลิปที่ทาง Chris Energy ได้อธิบายเกี่ยวกับเรื่องของการทำ seismic survey แล้วก็เรื่องของการอยู่ของปิโตรเลียมใต้ดินนะคะเป็นคลิปที่น่าสนใจตามกันไปเลยนะคะ
Before the expensive process of drilling for oil and gas begins, underground reservoirs are often remotely detected through a seismic survey. A seismic truck first sends sound waves down through the subsurface rocks. That energy is then reflected by the various rock layers back to the surface and detected by the seismic receiving equipment. Seismic data is displayed similarly to a cross-section of the Earth. Seismic data with colored attributes depicts a much greater level of the subsurface detail. Underground geologic features then become much easier to identify and target. Once the potential oil and gas reservoirs are identified in the subsurface, drilling and production may begin.
อันนี้เป็นภาพการทำไซสมิกในทะเลนะคะจะมีเรือหลายๆลำอันนี้เขาวางเรือไว้แค่ลำเดียวอันนี้มาต่อเลยนะคะ
Seismic surveys performed along a linear path generate a two-dimensional image of sound energy reflected to the surface. These energy reflection patterns reveal variations in underground geology. The reflection patterns also correlate directly to significant features of the subsurface geology. Seismic data can indicate the presence and location of formations that are likely to hold hydrocarbons. Seismic surveys make it possible to drill more accurately into these hydrocarbon reservoirs. Millions of dollars can be spent drilling an oil or gas well, so it is very important to gather as much information as possible at every stage to determine if it makes good business sense to continue drilling and complete the well. Logging a well is one very effective way oil and gas companies gather detailed information about the different layers of rock they've drilled through. This gives greater certainty about whether or not hydrocarbons are present. If the well is not promising, the process can be stopped and the well abandoned before incurring the large costs of completing the well. Once the well has been drilled to its target depth, the drill pipe and bit are removed from the hole. A specialized logging crew and equipment are brought on location. The crew assembles a probe, which is several different logging tools connected together. Depending on the number of tools in the assembly, the probe may be 70 to 120 feet in length. Using diverse scientific techniques, each tool performs a different kind of measurement of the rock and fluid properties within the geological formations surrounding the wellbore. The probe is lowered down into the wellbore on a wire line until the top of the probe is below the target depth. The process is carefully monitored by the well logging crew and geologists. As the probe is raised back up the hole, the various logging tools are activated by computers on the surface that produce a graph called a well log, which represents the geologic properties of the layers below the surface. On the well log, the gamma ray tool measures any radiation emitted by the rocks. Rock with lower amounts of radiation is called cleaner rock, such as limestone and sandstone. These are more likely to contain hydrocarbons than dirty rock. Notice that near the top of the log, the line is relatively flat and the reading is consistently high, indicating dirty rock, likely shale. But near the bottom, the reading fluctuates because the logging tool is entering a sandy area which has little radiation and could contain oil or gas. This data is called the apparent water resistivity curve. It indicates the potential for water in the rock formations surrounding the wellbore. At the top of the log, the line is at the left, which indicates more than likely the formation is wet or shaly. As we move down the log, the measurements change drastically. This indicates a quickly changing mixture of shale or other water-bearing formations on the left, to sand with the possible presence of hydrocarbons as the curve moves to the right. This next reading, called the spontaneous potential curve, shows geologists when the instrument passes from one rock formation to the next. The spontaneous potential tool uses two sensors, one at the surface and one down the hole, to compare the natural electrical charges at the surface with the underground rock. Some layers of rock have a positive charge compared to the surface, while others have a negative charge. A shift to the right on the log indicates a positive charge, usually associated with shale. A shift to the left indicates a negative difference, usually associated with sandstone. The center section of the log shows readings from the resistivity tool. The overlapping lines are 6 resistivity curves, each one measuring at a different distance from the wellbore how well the rock conducts electricity. The left side of the grid shows less resistance to electricity, while the right side denotes greater resistance. Oil or gas-bearing rocks are less conductive and therefore more resistive to electrical currents. Notice that for most of the vertical distance, the rock has less resistivity. This is likely shale. The higher resistance is likely an indicator of sand, a layer that can hold hydrocarbons. The reading from the neutron porosity tool, which can count how many hydrogen atoms are in the surrounding rock, can be seen in this section of the log. A higher concentration of hydrogen indicates the possible presence of oil. When the curve moves to the right, this indicates fewer hydrogen atoms. So as we move down the wellbore, we can see that the amount of hydrogen is generally decreasing. This means there is either very tight rock that cannot hold oil, or gas may be present. Working in tandem with the neutron porosity tool is the density porosity tool. It measures the space between the electrons in the rock, also known as bulk density. Near the top of the log, there is a greater amount of density, but as we move down the wellbore, the log indicates that the rock is becoming less dense. You'll notice that in this section, the density porosity curve and the neutron porosity curve cross over. This is significant. Whereas the neutron curve indicates either tight rock or gas, the density porosity curve tells us that the rock is more porous and therefore cannot be tight rock. This area indicates the high probability of natural gas. The next curve represents the measurements taken by the sonic tool. It shoots sound waves into the formation and records the time they take to return. Dense rock will have a faster travel time, while porous rock will be slower. Finally, on the left edge of this section, we see the reading from the caliper tool, which measures variations in the size of the wellbore. These variations can affect the accuracy of the other tools on the probe. So based on this measurement, the computer recalibrates the readings from the other tools as necessary. These are the most common logging tools used by oil and gas companies to gather information about the rocks and any fluid or gas content thousands of feet below the surface. There are numerous other tools designed for specific logging situations. The more complicated the geology is, the more diverse the set of logging tools needs to be. None of these tools by themselves can provide sufficient information to make an informed assessment about the well. But combined, these tools offer a more comprehensive and reliable perspective. When trained geologists look at well logs such as this, there is enough information for them to literally envision what the subsurface looks like. Because most wells are logged, oil and gas companies can research these logs to evaluate prospective drilling sites. When a company plans to drill in a new area, they can look at the logs of nearby wells called control wells. Lining up the logs, adjusting for variations in the surface altitude of each well, the geologist can get a good idea of the rock structure and possible presence of hydrocarbons across the area. This information is very helpful in identifying promising well sites before drilling begins.
ท่านผู้ชมคะแนะนำให้เข้าไปดูเองนะคะแล้วก็ขยายให้เต็มจอขอคลิปวางไว้อย่างนี้แล้วก็ส่งลิงก์วางไว้ให้ด้วยเข้าไปหาความรู้เถอะค่ะอันนี้เป็นสิ่งที่เราควรจะรู้ขอบคุณและสวัสดี